Another video with more examples from the Hawk section 6.1. Let's just get right to it. What are we going to get next? Oh, well, it's not a good start. Let's get up here. Okay, so on the first problem, it's the only problem that I'm going to include all of the directions from Hawks. It's like the other ones, so just keep that in mind. All of the directions will say this. Okay, so let's just do this problem, and it's kind of small here, so let me rewrite it. The problem asks us to multiply x to the fourth times x to the negative 1. What do we got going on here? We have multiplication, same basis. So we know there's a shortcut for that. The base of our answer, well, it's going to stay the same. That's easy, huh? It's going to be x. And what do we do with the exponents when we're actually multiplying? The shortcut says add them. And 4 plus a negative 1 is 3. And there's nothing more to be done with that. So that's the answer we will put into Hawks. Well, I just keep getting down to there. Let's see. The next one. Oh, I love this problem because there's lots of negatives. Are these two little horizontal lines, do they mean the same thing? No, they're different species. This little horizontal line in front of the big 7 is what we think of on the number line. We've got a positive 7, flip it over, and it becomes a negative. And so that's actually talking about a negative number. But the exponent has a negative in it, but that has different meaning. It's an instruction. So what does the exponent, let me erase this, what does this negative in the exponent tell us to do? It tells us to take the base, which is what? Who does that exponent apply to? It applies to that whole thing inside the parentheses and the exponent, so everything except that negative, and it tells it to go downstairs. So if that goes downstairs, it's going to be negative 7 to the first, and there's just a 1 left over, so we got to clean that up a little bit. We've got 1 over, and what is negative 7 to the first? What's anything to the first power? Itself. And the final thing we're going to do here, that's true, it's equal to 1 over negative 7, but we don't like to have negative in the downstairs, so we let that negative float up, and our final answer would be negative 1. Okay, do you notice, I can't leave that one just yet. Do you notice this negative here in front of the 7 and the negative in front of the 1, they don't cancel because they're not the same kind of negatives. Okay, so next one. We got to get through these. Next problem. Let's just go slowly here. Okay, in this problem, we've got basically two different species. We've got numbers and we've got y. So we're going to deal with those separately. The numbers, negative 6 and negative 2, those are just regular old numbers. So you know how to handle negative 6 over negative 2. What is a negative 6 over negative 2? It's equal to 3. And another, let me just kind of this the long way. Negative 6 divided by negative 2 gives you, you divide both of those by negative 2, you would get 1 and 3. So we end up with 3 upstairs. And we'll see if we need that 1 downstairs. And then now, let's just take a look at this separately. We've got y to the 4th over y. We're dividing same basis, so we know the shortcut is to just subtract the exponents. I don't see an exponent down here, so we know that there's an implied 1. So that part gives us y, 4 minus 1 is 3, so we get y cubed. And we don't even need the fraction at all because we don't have anybody downstairs, so I'm just going to erase it. Next one. Oh, we've got a number. We've got another number that's a base to an exponent. And who does that exponent apply to? So that's what I'm interested in. That exponent applies to the 4. Since that negative's there, that tells us, oh, we're going to have to do something with the base and the numeric part of the exponent. That means we're going to have to send that guy where he's not, which is downstairs. So just that part of it becomes 4 cubed. What about the 3? Well, it's just 3 times that. We can just put 3 up here. Nothing happens to the 3. It has no exponent. There's no instructions. Okay, so we're almost there. Expand the numeric part of your answer means if you can multiply something out using exponents, go ahead and do it. We would get 3 and 4 cubed is 64. Okay, let's chop chop. Oh, I love this problem too. Oh, experts. I see that 0. Be really careful. Who does that 0 exponent apply to? It only applies to the x, so it's only that part that I've circled in red that's equal to 1. That 2 in front is still just 2. And the same that y, that only applies to the y, so that part is the only part that equals 1, and there's still a 2 in front. So we have, let's simplify that, 2 minus 2, and we get 0. Okay, next one. Oh, I keep doing that. Where are we? Up, there's a similar one, but not quite the same. Several ways to look at this, so I'm going to just do it really quickly. I notice we've got same base being multiplied. So I know there's a shortcut to that. The answer is that same base, and the shortcut says add exponents. When you add the exponents, 0 plus 3 is 3. So there we've got negative 3 to the third, which means negative 3 times negative 3 times negative 3, end up with a negative 27. I want to look at this problem just one more way before I move on. This time I'm going to say, hey, wait a second. There's a 0 exponent and it applies to this whole thing. So that means, oh, this is getting a little bit confusing there. So that 0 applies to all of this, so it doesn't even matter what's inside there. Anything to the 0, except 0, is equal to 1. So times negative 3 cubed, we would get the same thing. Let's just bring this down here, negative 3 cubed, and we'd still get a negative 27. Let's see, there's one more problem. Oh, it's very similar. We've got same base, okay? So we're multiplying, so our answer is going to have that same base. So I'm just going to that negative 2. And what do we do with the exponents? We add, and 3 plus 3 is 6. Now we have to chunka, figure out what that is. And if you multiply negative 2 times itself 6 times, you're going to get a 64. And you see why it's going to be positive? Because you have an even number of negatives. And I think that's the last problem. So I will see you when we start finally 6.2.